All right, so hello, my name is Joey, and welcome back to the OneClass live stream. What we're going to do today is we're going to go and verify solutions in subjects, specifically in math. So here at OneClass, what we're doing is, if you haven't, if it's the first time you're watching this, here at OneClass, what we're doing is we are providing online videos and live streams and resources for everybody to access for free. And what we're doing here is that we are kind of creating videos of verifying solutions so that you have the best results going forward. If you are getting ready for a test or an assessment, or just looking ahead, or just catching up, you can access those resources and use these resources to improve your grade at school. So despite the school closures because of COVID-19, what we're doing here is we are providing another alternative solution to learning as well through videos and through resources that we curate here. So my name is Joey. I'm currently a secondary school educator in Ontario, and my teachable subjects are chemistry and mathematics. So that's kind of my background coming into this. So what I have for you today is I have 10 questions from basically the pre-algebra, algebra 1, and geometry kind of questions here. So we're going to do all of these problems together, and yeah, let's get started on these problems. All right, so our first question says here, so Tom and Amy set their alarms on their phones to sound at 6:45 a.m. Both alarms sound together at 6:45 a.m. Tom's alarm then sounds every 9 minutes. Amy's alarm then sounds every 12 minutes. At what time will both alarms sound together? So let me write this down first. So I'm given a bunch of information here. So I have Tom's alarm, and then I also have Amy's alarm, right? So if Tom's alarm, it sounds every 9 minutes. So every 9 minutes. I'll write the word every 9 minutes. And then Amy's alarm sounds every 12 minutes here. And we know that they both ring at 6:45, right? Both alarms sound together at 6:45. So both ring at 6:45. It's asking us at what time will both alarms next sound together. So if you look at, I'll use blue for Tom here. If you look at Tom's alarm here, it rings every 9 minutes, right? So so you can think of it as being in a multiple of 9. So if you write down the multiples of 9 here, you have 9. It's going to ring every 9 minutes. So at the first 9 minutes, and then it's going to ring after 18 minutes, 27, 36, 45, and so on and so forth, right? It's going to ring every 9 minutes, and it doesn't alternate from that here. So every 9 minutes it's going to ring. If you convert that into time, we'll do that as our last step here. So let's leave that for the last step here. And then for Amy's alarm, it rings every 12 minutes, right? So every 12 minutes, it's going to ring. So the first time it's going to ring every 12 minutes. So 12 plus 12 here is another 24. 12 plus 12 is 36, and 48, and then 60, and so on and so forth. And they're asking us at what time will both alarms sound together, right? So I'm looking at these numbers here, and I'm saying which one from Tom's set of numbers and from Amy's numbers are the same. And as you can see here, 36 is the common number here, right? 36 would be, you can think of it as my lowest common multiple between 9 and 12, right? So therefore that means after 36 minutes, the alarms will ring together, right? Alarms will ring together. So we know it's after 36 minutes here, but what does that mean in time? So remember, the starting time here was 6:45. I'm going to have to add 36 minutes to it. So starting time, I'll just say start time here is 6:45, and I'm adding 36 minutes here. So how I would visualize this is I would add basically half an hour plus 6 minutes here. So half an hour of 6:45 plus half an hour, I would maybe do this guy here, would be 7:15, right? 6:45, so yeah, quarter to 7. If you add half an hour to that, it's going to give you 7:15. So it'll cancel out this half an hour here because we added this already. And all we have to do is add 6 minutes to 7:15, and you get 7:21. So that means our answer here is at 7:21, both alarms are going to sound here. So this is here is our final answer. So let's look at the solution here. So given Tom and Amy has set their alarms to sound at 6:45, good. They sound at every 9 minutes, so that's good. So they were at 9, 18, 27, 36. Amy's is 12 minutes, so after 12, 24, 36, and 48, which is good. And since timing of both the alarms match after 36 minutes, therefore the next alarm will sound after 6:45 plus 36 minutes, which is 7:21 here. So this here is the correct answer. Solution is correct. Good analysis. So they use the concept of lowest common multiple here, right? Sweet. That's number 1. So number 2 is asking, is it possible if 3 points are coplanar, then they are also collinear? Justify your answer. So possible if 3 points are coplanar. Then they are collinear. So when we look at this problem here, we have to define 2 things here. We're defining the term coplanar, and we have to define the term collinear, right? So the term coplanar basically means that they belong to the same plane, or the points or the set of points belong to the same plane. So it belongs to the same plane here. And then finally, collinear. So collinear just means that it follows a formula, follows a set formula for, like, you can think of it as a equation of a line. Follows a constant kind of increase here. So again, for example, this graph here would be collinear because all the points lie on that line. So I'll say belongs to the same line here. Belongs to the same line, or you can say linear function. Okay, so it says describe if 2 points are coplanar, then they are also collinear. So let's draw an example here, and I'll draw 2 examples here. Use the line tool just to make it a little bit more easier. So I have 2. So I'm gonna have one line here first. So I have one line here. So for example, if these 3 points here, if 1, 2, and 3 here, and the coordinates don't really matter, but in this case here, my 3 points here are coplanar. Basically, anything I put in this XY plane here will be coplanar because they belong in the XY plane, right? So immediately, these points here are coplanar. However, they're also collinear as well because, as you can see, all these points lie on the same line. So they are also collinear. However, what if I had something like this? What if I had something like this? And what if I had something like this? Like if I had this graph like that. This is still coplanar, right? These guys here are still coplanar. So still coplanar. However, these are not collinear now, right? Because they don't belong to the same line or function, right? As you can see here, I have 1 point here, 1 point here, and 1 point here. I can't make a linear function. It's not like a slope that's a constant slope, right? In this case, it's a quadratic function here. So this point would be not collinear. So therefore, we can say that is it possible that if 3 points are coplanar, then they are also collinear? It is possible, So in this case, it is possible, but not always the case. So our answer here is that, so is possible if 3 points belong to the line, the linear function. Not possible besides that part. Not possible besides that. So that's kind of our answer here. So in this case, they wrote the exact same thing. It says, in this example, points are collinear, so they belong to the same plane, which is good, and they're also collinear because we can join them with a straight line. They belong to the linear function. This is like my first guy here. And then in this case here, they made a triangle here. It says points here are also coplanar, right? They belong in the xy plane, but again, they're not. This is not a linear function here. I can't throw one straight line and go through all of these 3 points in one smooth line here. So as you can see, this here would be coplanar, but not collinear here. So this solution here is correct. Solution is correct. Good use of examples here. All right, that's number 2. Number 3 is asking us, how do you write 3/20ths as a decimal? How do you write 3/20ths as a decimal? Well, all we have to do to write 3/20ths as a decimal is we every time we look at what a decimal is, the term deci, or the prefix of the term, means in terms of 10, right? It's a factor of 10 here. So in this case, we have 3/20ths here. So what we're going to have to do is we are going to have to either, there's a lot of ways to actually do this problem here. We can use division here to divide these two terms here. But if I know my denominator here is can be converted into something that's a multiple of 10, then I would, or a factor of 10, sorry, then I would actually convert this decimal into an equivalent fraction first before I do a decimal here. So 3/20ths, as I know, I want to either convert it into basically either 10, hundredths, or 1,000 here. And in this case, I would probably convert it to 100ths here, because as you can see, I have 20 on the bottom here, right? So I'm going to have to, it's going to equal something over 100 here. So 20 times what would give me 100? 20 times 5 would give me 100, which means I have to multiply 5 on the top side here. So 3 times 5 here is 15. So 15 over 100 as my equivalent fraction here. And if I want to change this into decimal, it's very, very easy, right? All I have to do is I have to, again, 15 over 100ths, it's lower than 1. So I'm going to have 0 point. And then obviously, because I have a hundredths case, I'm going to have 2 digits here, 1 and 2, because this here is a tens digit. This here is the hundredths digits. And then what we can do is, again, 1 here, in this case, it's the ones digit, and 5 here would be the hundredths digit here. So this is 15 over 100 is 0.15 in terms of our decimal here. So this solution is solved. So this here is correct, right? So what they did was, instead of doing the factor by 100, they actually simply just divided the decimal here. And I'll show you how to do that as well. There's a lot of ways to convert here. But what you could do is you could put 20 here, and you could divide it by basically 3.000. And we could do this long division for us to figure out what the decimal here is. So decimal was placed here, so which means I would get this decimal here as well. 20 goes into 30 one time. 20 here. 30 minus 20 is 10. Bring down the 0. 20 times what equals 100? 20 times 5 equals 100. And this would be a remainder 0 here. So we get 0.15, which is the exact same thing as what we got on the using the equivalent fractions here. So this solution here is correct. It's a great analysis as well. It says, consider the function y equals 2x minus 3. I don't have the, is it this guy here? Let me see if it's yeah, okay. So this here is a question. Let me see if I can. Here you go. Okay, so this is question 4. It's asking us, demonstrate your knowledge by giving a clear, concise solution to each problem. It says, consider the function y equals 2x minus 3. Complete the following function table. Okay. So I'm giving this function here, which is y equals 2x minus 3. And then I have this function table here, right? So let me just let me use these lines and draw this out first. So I have 1, 2, so I'm going to have my first column here. I have 4 lines here. 1, 2, 3, 4. Okay, so at the top I'm going to have x, x, 2x minus 3, and y. I have the red here, or actually reds and blacks would be -2, -1, 0, and 1. And I have to complete the table here, right? So I can exit this here. And basically all we're going to have to do is basically just substitute our points, right? So 2x minus 3 here is simply just, I can substitute in x equals 2 for 2x minus 3, right? So let me just do a sample guy here. So I can say that, I'm going to say that 2, I'm going to substitute my minus 2 here, right? So minus 2 minus 3 here. So 2 times minus 2 is -4 minus 3, which means it's -7 here, right? So my first point here is -7. I can do the exact same thing with -1. I take 2x minus 3. 2 times -1 minus 3 here. 2 times -1 is -2 minus 3. So 2 minus 2 minus 3 here is -5, right? I can do the same thing with 0 as well. So 2 times 0 minus 3. 0 minus 3 is -3. And finally, I can do the same thing for 1, right? 2 times 1 minus 3. 2 times 1 is 2. Minus 3 is -1, right? So I have all these points here. And these points are actually equal to my y value as well, because I stated that y equals 2x minus 3. So these two function tables are actually the exact same. So I can write down -7, -5, -3, and -1 here. And this will be my correct answer for number 4. It's exactly the same thing. They did the exact same thing, and they put the work in here, which is awesome. -7, -5, -3, and -1, and the exact same table as well. So, and they also graphed this function as well. Perfect. And it shows a linear relationship between those numbers here. So this solution is correct. 4. I feel like I've already answered this question quite a bit, but we can do another one here. So how many quarts are in a gallon? How many quarts in a gallon? So again, we're working in the empirical system here, and we're measuring volume, right? So empirical system, measuring volume. So you can say that basically, I know that here 1 gallon equals 4 quarts, right? And then obviously I know the relationship between quarts and pints and cups and fluid and cups to fluid ounces. But the question is simply asking how many quarts are in a gallon here. So 1 gallon here equals 4 quarts. So this here is my correct solution and my answer here. There's nothing really we need to do to this math problem. It's just asking us what the conversion factors is for how many quarts are in a gallon. So we should know this by now in terms of the empirical system as well. So again, 1 gallon here equals 4 quarts. So again, the solution here is correct. It says how many ounces in 500 milliliters. And I think the next question is going to be the exact same. So I'm basically going to do this problem. I'm going to do this problem once and then move ahead here. So I think this is question 6. Yeah. I might finish early today because I think I doubled up on a question today here. So it says how many ounces are in 500 milliliters. So again, we have, in this case, we have ounces here, which is in the, this here is in the empirical system. And this guy here is in the metric system, right? So we're going to have to find some relationship between ounces and milliliters here, but they all measure volume here, right? So it's just a different measure of volume here. So it says here that if I want to convert ounces to milliliters, I know that my conversion factor would be 1 fluid ounce would equal 29.5735 milliliters here. So if I know this conversion factor here, I have to now find how many ounces are in 500 milliliters, right? So let's see. If I have 500 milliliters here, I'm going to multiply that by how many fluid ounces are in a milliliter. I have 29.5735, right? So I'm going to say 1 fluid ounce divided by that's going to be 29.5735 fluid ounces or milliliters in a fluid ounce, right? So in this case, the milliliters are going to cancel out and get 500 times 1 divided by 29.5735, which would equal my answer here, 29.5735, which would give me 16.907 fluid ounces here. And this solution is my answer here. 16.907 will be my answer for this problem here. As you can see, they did the exact same thing. 1 milliliter equals 1 divided by 29.5735, which is what I did here. 500 milliliters times 1 fluid ounce is 29.5735. So therefore, 500 times 1 over 29.5735 would give me 16.901 or 16.91 ounces or fluid ounces here. So the solution here is correct. Good analysis. And I believe the next question is the exact same question here. Yeah, it's the exact same question here. It says how many fluid ounces are in, or how many ounces are in 500 milliliters. And as you can see, they also did the conversion, but I believe they did conversion from milliliters to fluid ounces. So they got 0.033814. It still gives you the exact answer of 16.907 here. So I'm going to say solution is correct. Good analysis as well. So that was number 7. So number 7 was simply just a repeat of number 6. I picked it just so I could verify the solutions together here, because they're the same problem. So repeat. And then 8 here says, how do you simplify the square root of 72? So if I were to simplify the square root of 72 here, what I'm going to do is, again, I'm going to break down this radical into its prime factors here. So I know that for a fact that this 72 evenly divides by 2. So I'm going to, again, take out root 2 here. I'm going to divide 72 by 2 and get 36 here, right? It's good. So I have root 2 here. I'm going to do the exact same thing with, in root 36 here. I know for a fact here, just because root 36 I know is one of my square roots actually becomes a good integer, and I know the square root of 36 here is 6. So therefore, my answer here is simply just 6 root 2 here, right? This is just the simplified root version, simplified radical form of root 72. So this here is my answer here. 6 root 2 is my answer here. So as you can see, they did the exact same thing. Root 72, they broke it up into 2 and 36, and we know that root 36 here equals 6. So 6 root 2 here is our answer here, and they did the exact same thing. So the solution is correct. Good analysis here. Okay, number 9 says that if 2/3 is added to a reciprocal of a number, the result is 17/3. Find the number. So if 2/3 is added to a reciprocal of a number, the result is 17/3. So it equals 17/3. Find the number. So when we talk about reciprocal of a number, what does that mean? So reciprocal of a number. So reciprocal of numbers simply means that it's, if I want to take the reciprocal of a number, I basically flip it, or basically I do 1 over that number, right? So if I had x, for example, the reciprocal of x would be 1 over x, right? I'm dividing it by 1 over that specific number here. So I'm going to have here this, so in this blank, I'm going to hit 1 over x here, because this here is my reciprocal of x. And then what I'm going to do is I'm going to simply just algebraically solve this problem here, right? I have 1 over 2/3 plus 1 over x equals 17/3. I can move this 2/3 to this side here and subtract both sides by 2/3. So 17/3 minus 2/3 here. And I have 1 over x equals 17/3 minus 2/3. They have the same denominator, so I can just simply subtract the numerators. I'm going to have 15/3. And then I know that 15/3 is actually just 5 here, right? So I have 1 over x here equals 5 here. And then finally, I can simply just, I can take the reciprocal of, or what I can do is, again, I have 1 over x. I can multiply both sides by x here to get 1 equals 5x. And then finally, I can divide both sides by 5, right? So I get x equals 1 over 5. So this here is my solution for the number here. This x here would give me the this equation, would satisfy this equation. So x equals 1/5. As you can see, they also wrote x equals 1/5. So the solution here is correct. Good explanation. We have number 10 here. It says how many pints are in 2 cups? I believe I only have 2 more questions actually for the set, just because I picked a repeat. So I might have to pick some more questions for us later on. It says how many pints are in 2 cups? So again, remember pints and cups are in the empirical system. And again, I have a table, right? So again, I have 1 gallon equals 4 quarts. I know 1 quart equals 2 pints, and 1 pint equals 2 cups, right? So let me write that down. I have 1 gallon equals 4. That's a 2. Sorry. 4 quarts. 1 quart equals 2 pints. 1 pint equals 2 cups here, right? So if it says how many pints are in 2 cups, as you can see, I have 2 cups here, it's going to equal 1 pint. So the solution here is simply just 1 pint would equal 2 cups here. So like so, it says 1 cup equals half a pint, so 2 cups equals 1 pint. Answer, in 2 cups there is 1 pint, so 1 pint here is the correct answer. So we don't even have to do any math here. Solution is correct. Good explanation. Just because it's part of our conversion factors here. So solution here is correct. And then finally, for this this set of questions here, we have number 11. It says, what is the square root of 1600? So the square root of 1600. Square root of 1600, again, we're going to use this term of prime factorization. And what we're doing is we're taking out numbers that we think that are prime factors of 1600 here. So the best thing I would do is every time I see an even number, I would always take out 2, right? So I'm going to take out root 2 here. And then I'm going to get 1600 divided by root 2. or 1600 divided by 2 is simply just 800, right? So I have 800 here. 800 is another even number, so we can take out another root 2. So 2 root 2's now, and then 800 divided by 2 is root 400. This here is good. I can do the exact same thing and take out this number again. So root 2 times root 2 times root 2 times 400 divided by 2 would be 2 root 200. And then we do the exact same thing one more time here. So root 2 times root 2 times root 2. Take out another root 2 here. 200 divided by root 2 is root 100 here, right? And now at this point, what we can do is I can simply say that root 100 here is equal to 10, right? So I have root 2 times root 2 times root 2 times root 2 times 10 here, right? Because root 100 I know is 10. So I have 10 here. Root 2 times root 2 is simply just 2. And then root 2 times root 2 is simply just 2, right? So I'm going to have, so these, all four of these terms cancel out. So it's 10 times 2 times 2 here, which will equal 10 times 4, which is 40. So which means the square root of 1600 is 40. So this here is the correct answer. This here equals 40. And as you can see, what they're doing here is they are, what they're doing is, they just knew that it was the square root of 40. Or they just knew that the answer was 40 without really doing any steps here. So I would say the solution here is correct. Solution is correct, but no steps were shown. No steps were shown to figure out the answer. So that's probably going to be it for this set of problems. So what I'm going to do now is I'm going to actually, I'm going to take a few minutes to go and select maybe like three more problems for you guys, and then we will do those as well to finish up for this hour here. So just give me a second. So I'm just going to select three more problems for you guys here. All right, here we go. I think I selected 4 more problems for us here. So it's back to question 1 here. Let me see. 1, 2, 3. Yeah, I selected 4 more problems here. Oh. Okay, so let's work on these 4 more problems and we'll call it a day here. So it says here, how do you write 2.5 as a fraction? So 2.5 as a fraction. So what I would do first is I would actually write it as a mixed fraction. So again, in the whole number and the fraction part. So again, my whole number in this case is 2, right? It's whatever is on the left of the decimal here. So it's simply just 2 here. And then 0.5 is simply just 5. It's half of something, or 5/10 or something, right? So as decimal place, because it's in the 10th place, which means my denominator here would be 10, and then I would have whatever the numerator is, just a number here. So it's just this 5 here, right? So if 2 5/10 would be in a mixed fraction here. But I know for a fact that 2 5/10 I can reduce it to the lowest terms, right? So 2 5/10 would also equal 2 1/2, right? I can simply just divide this number by 5, this number by 5. I would get half here, right? I'm reducing it to the lowest terms. So if 2.5 would be my fraction, and if I were to convert this to an improper fraction, so this here is a mixed fraction. If I want to convert it to an improper fraction, what I would do is I would take 2, I'm going to multiply it by the denominator, which is 2, so I'm going to get 4 plus the numerator here, which is 5. So I'm going to get 5 over, and then simply just 2 here. So 5 over 2 is 2.5 in fractions, and this solution here is correct here. Fraction form of 2.5 is 5 over 2. Solution is correct. Good explanation. Number 1. Number 2 is asking us, what is the square root of 625? So I have the square root of 625. So again, we're using the exact same as we're going to use prime factorization again. So prime factorization. But this time I don't have an even number, so I can't take out 2 from 625. It's an odd number here. So what I'm going to do is I'm going to take out the next obvious number, which would be 5 here, right? And anything that ends in 5 or 0 is divisible by 5, right? So I'm going to take out a 5 here. And then I'm going to get whatever 625 divided by 5 is, which I believe is 125. I think I've done this problem before, now that I think about it. Maybe in a previous stream here. A lot of repeats today. So 125. And again, I'm going to take another root 5 out from 125 here, right? So 125 divided by 5 would be root 25 here. And finally, I know that root 25 here is simply just 5, right? So I can cancel out root 5 and root 5. That's going to just simply equal 5. So 5 times 5 here, which is simply just 25. So the root of 625 here is a perfect square. It's going to give us 25. And this here is correct. Plus or minus 25 would be the more correct answer here. So this solution here is correct. Good explanation here. Did they take out a 5 like I did? No, they just said it was perfect square. So I'll just say here, solution is correct. Could have provided a step, an explanation as how you got 25 as the answer. Here is, it says here, number 3 here, it says, how do you find the square root of 33? Lots of square root problems today. Square root of 33. So if I were to do the prime factorization for this one, I would take out the 3 first. I would have root 3. If I divide 33 by root 3 here, I would get root 11 here. And this this means that I have to stop here, just because I have 2 prime numbers here, and that's going to be it, right? So root 33 is actually the most simplified form of the number here. So what we're going to do is we're going to have to use the method-asked solution for us to solve for the square root. So this is kind of the method-asked solution. It's kind of like long division here. So let me just write this down for you. So I'm going to have 33 here, and I'm thinking of a number that would square into 33. So the closest square would be 5, right? So I wouldn't have 6 because 6 squared is 36. 5 squared would be 25. So 5 squared would be 25 here. So I have a 5 here. You can put a 5 here. I have 25 here. Subtract these two numbers, I would get 8. And then finally, I would basically double the quotient here. So 5 times 2 here is 10. And then I'm going to basically add a 0 here. I'm going to add 2 zeros here. And then I'm thinking of basically a number that would go into I'm thinking of another squared number here that would go into 800, and I'm focusing on this digit here. So in this case, it would be 7, right? So 7 here, I would get 7 here as well, and 107 times 7 is 749, which is less than 800, which is good. Subtract those two numbers, I would get 51. Again, I would basically double the 7 here, which means I would get 14. So I would get 114 here. Add 2 zeros. And finally, if I had 114 here, I need to make room for one more digit here. And have 51 and 0 here. So again, I'm looking for a number that that is going to square into 5100. In this case, it would be 4, right? So this would be 4 here. 4 on top. 1,144 times 4 is, I believe here, it says here 4,576. As here, I would get some number here. So therefore, my square root of 33 is going to be plus or minus 5.74 here. And this will be my answer for this solution. And they also wrote 5.74, so the solution here is correct. Solution is correct. And then finally, I believe this will be my last problem of the day. Will be number 4, which is what is 5% of 200? What is 5% of 200? So in order for us to solve for this problem here, I'm going to have to change the percentage into a decimal, right? So I have 5% here. What I'm going to do is 5% here. I'm going to divide it by 100, right? Because percentages are always of 100%. So I'm going to have 5 divided by 100 here, which will equal basically then 0.05, right? I simply have to move 5. I'm moving the decimal place 2 places behind the 5 here. And then all I'm going to do is I'm going to multiply 0.05 by 200, right? So 0.05 times 200 here, and then this would give me a value of the answer here. So I can either do this, or I could even do the 5 over 100 times 200 here. It doesn't really matter which one I do because they're both equivalent in terms of the decimal and the fraction here. So if I were to do the fraction here, this would cancel out. I would get 2 here. 5 times 2 here is 10. So this here will be my answer for this problem here. What is 5% of 200? It is simply just 10 here. So these two are my solutions here. Again, the answer of 5% of 200 is 10. So solution here is correct. Correct. Good explanation. So that's going to be it for my video here. So again, thank you so much for watching the stream. Again, I'm going to stream again probably at 12. I'm probably going to go through the exact same problems. Again, some pre-algebra, some algebra 1, and some geometry as well, just because we got a lot of problems this week for a lot of mostly square roots and a lot of conversions. So I'm going to focus more on that for today. Again, my name is Joey. I stream basically on Monday, Wednesdays, and Fridays for math, and Tuesdays and Thursdays for chemistry, so you can feel free to tune in. Again, all these videos are going to be recorded on our OneClass YouTube channel, so feel free to check us out there. So you can kind of go there and access those videos. If you had trouble, you can always pause, fast forward, or rewind to catch things you have might have missed, or and kind of work at your own pace as well. So as always, thank you so much for watching. Stay safe. Stay healthy, and have a great day. Take care.